Now, in frequency response analysis, some basics are there. You have to know the basics before you solve the Nyquist plot, polar plot, or Fourier plot, anything. So you just have to know that. So now in this real axis and imaginary axis, we have taken this is a point A, this is a point minus A, and this JB point, and this, that is minus JB point. So and we have chosen that there is a pole on A plus JB. Maybe there is a pole on A minus JB, minus A minus JB, A minus JB. So in that poles, what would be the magnitude and what would be the pole? You have to remember this first. So just you can see that I have written it clearly. So these are becoming and clearly, most clearly, this is 180 degree plus tan inverse b by a. Only this thing is changing, the theta is changing. 180 degree minus tan inverse b by a, and here is plus, here is minus, and here 0 minus tan inverse b by a, that will become minus tan inverse b by a. Only you have to remember that. After that, one thing you have to remember, this order. At first you will start from here, type 0, type 1, type 2, type 3, and after that 0, 1, 2, 3, 4. What is this? So before plotting any polar plot, we have to find out what is our starting point and what is our finishing point. So the type will define the starting point and the order will define the ending point. So you can see if type 0 and order 1, then it will start from here and end at this. If type 0 and order 2, it will start from here and end at this. If order 3, then you will end at this. If some system is type 2 and it's order 4, so type 2 and order 4, it will end at here and start from here. So this is the main concept. I have written that type will be the starting point and order will be the ending point. Now, according to this, I have made one table. Okay, this is type 0 and this type 1. What will be the cases? You can see here. You can just go through it or you can just calculate it. I will show it on polar curve. You can calculate it also, but it's easy to remember. You can also verify that. Now see that if we are taking type 1 system, one type 1 system is here, and you can see that if we put s equals to j omega, that will become k by j omega, and the magnitude will become k by omega only, and the angle will become minus 90 degree. Okay, so why minus 90 degree? For every value of omega there will be minus 90 degree. If there is 2 omega, that means omega square or something, then it will be minus 180 degree. For every value of omega there will be 1 minus 90 degree. So vary the omega from 0, then the value will be infinity magnitude, and the angle will be minus 90 degree. If we put the omega value infinity, then the value is becoming 0, but the angle is 90 degree. So the polar plot will look like this. Just I have shown here. Okay, that is type 1 system. Okay, so type 1 system, order 1, this just look like this. And this we can verify type 2 also. For type 2, that is becoming omega square here, j omega square. For that magnitude is becoming omega square, and the angle is becoming as omega square is there, that is minus 180 degree. And you can check here also by varying omega, the angles are same, minus 180 degree, so it is lying on minus 180 degree. Okay, in that way for type 3 or type 4, type 0, everything is shown here. And one interesting thing is in case of type 0 and type 4, both are at 0 degree. So type 4 and type 0, both are actually same in manner. Now one more thing for polar plot calculation only, we have just taken a type 0 system which is of order 2. Now I will show that example also. So what is happening, the curve will look like this, because type 0 starts from here, and order 2, this is order 1, this is order 2, so this will end at here. But here what is happening, this is cutting the minus 90 degree axis here. So this frequency we have to identify, and for that there must be a shortcut. But before the shortcut, we have to go through the larger process or the longer process. And for that frequency there must be a magnitude, so we have to find out this both two. For that, what we have done, and one more thing, and that will be in time constant form. So 1 plus st1, 1 plus st2. Okay, so while we are doing polar plots, we again have to transfer in time constant form, then we will find out the omega y and y. So it's better to go through the shortcut method. So for that shortcut method, what we have done, we just put s in j omega at the place of s. So you can see here, and after that we have put it the angle k is as well 0 degree, and that will be omega t1 by 1 and omega t2 by 1. So in this we have put in the upper side nominator, so that will become like this. And after that what we have to do, this angle is cutting minus 90 degrees, so we have to write this. So tan inverse minus tan inverse of omega t1 minus tan inverse of omega t2 equals to minus 90 degrees. So minus minus gets cancelled out from everywhere, and if we put tan in both sides, tan inverse of omega t1 plus tan inverse of omega t2, that is equals to 90 degree. Okay, now actually this is a, this is b, so what will happen, tan a plus tan b. So tan a plus b, what is the formula? So tan a plus b formula is tan a plus tan b by 1 minus tan a tan b, right? So if tan a will if you write tan a, so tan inverse gets cancelled, and the remaining is omega t1. So this way this will be plus omega t2, and that will become omega square t1 t2, and that is equals to, if we put tan 90 here, tan 90, that is becoming infinity. So becoming it infinity, we must have to satisfy this 0, 1 minus omega square t1 t2, that is equals to 0. So omega square equals to 1 by t1 t2, so that will be root of t1 t2. And in this way, if we put the value of omega y where on the place of omega to find out the y, the magnitude. So our first point was 1 by root over 1 plus omega t1 square plus omega t2 square. So in place of omega we will put omega value 1 by 1 plus 1 by t1 t2 t1 square. Okay, omega will be see here, this is omega square, so omega square will be 1 by t1 t2, right? Right, this will be y. Now go through the polar plot example, you will understand.